Alright, you're welcome to this module on bearings and distances. Bearings and distances is a practical application of the things you have learned in the module of trigonometry. Basically, you will be applying the sine rule, you will be applying the cosine rule, you will be applying the Pythagoras theorem, you will be applying quite a number of those ideas you have learned under the module of trigonometry. So I want to advise that if you have got this module and you are not yet very comfortable, or you have not yet gone through our module on trigonometry, it will be advisable to go through the module on trigonometry first, so that you can be more familiar with the terminologies and the procedure we are going to be using in solving problems relating to bearings and distances. You can call trigonometry a prerequisite to bearings and distances. So if you want to find this module quite enjoyable, it might be necessary to first go through the module on trigonometry. What is bearing? Bearing is an expression for angular displacement from a reference point as measured in degrees. Bearing is an expression for angular displacement from a reference point in degrees. It can either be expressed in terms of three-figure bearing or as compass bearing. What is the difference? Three-figure bearing is quoted always with reference to the north, while the reference of compass bearing is always stated. A three-figure bearing is always quoted with reference to the north. For example, if I give you a bearing of 060 degrees, that is a bearing of 60 degrees, always with reference to the north. But when I give a compass bearing, I can say north 30 degree west, or I can say south 20 degree east. So the reference of a compass bearing is always stated. South 20 degree east means beginning from the south, move 20 degrees towards the east. So the reference is not necessarily north, but the appropriate reference is always quoted. However, with three-figure bearing, you will hear things like 274 degrees, 025 degrees. The reference is always from the north. Illustrations. Compass bearing example. For example, north 40 degree east. This is a compass bearing. And what this means is this. From the north, go 40 degrees eastwards. And that is it. Starting from the north, go 40 degrees eastward. So, the compass bearing of this point is, of a point that lies on this line, is north 40 degree east. And the equivalent three-figure bearing is 040 degrees. I just omitted the 0, but appropriately it should be written as 040 degrees because it's a three-figure bearing. So the equivalent three-figure bearing for this compass bearing is 040 degrees, where the value of 40 is always with reference to the north. Another illustration, for example, consider the compass bearing example that states south 50 degree east. What this means is this: beginning from the south, move 50 degrees eastwards. And that's it. Beginning from the south, move 50 degrees eastwards. So this is a compass bearing. And the equivalent three-figure bearing for this compass bearing is 130 degrees. Because 130 degrees is always with reference to the north. That is, if a line is at this point, then this line must be 130 degrees reference from the north. Remember that the total angle on a straight line is 180. So if this point is 50 degrees, then measure from the north, it must be 130 degrees. So the equivalent three-figure bearing of a compass bearing of south 50 degree east is 130 degrees. I hope you understand. South 50 degree east is this angle, the displacement of this line from the south axis. However, if you want to quote the angular displacement of this line with reference to the north, you will be measuring this angle. And if this angle is 50 degrees, then this angle is 130 degrees. Therefore, its three-figure bearing is 130 degrees. Further illustrations. For example, another compass bearing is stated as south 30 degree west. And this is illustrated as beginning from south, go 30 degree to the west. And this is this. That is, the compass bearing of this line is south 30 degree west. Alternatively, another way to state its compass bearing will have been to say west 60 degrees south. That will be this point. That is, beginning from the west, move 60 degrees south. I hope you understand. 60 degrees south. However, if you want to state it in terms of three-figure bearing, three-figure bearing is always with reference to the north. So, you are still dealing with this line. If you want to state its angular displacement with reference to the north, it will be this angle, which will be 180 plus 30, and that gives 210 degrees. So, the three-figure bearing of this line is 210 degrees, and 210 degrees from the north, because three-figure bearing is always quoted from the north. Further illustrations. Consider a compass bearing of north 10 degree west. This means beginning from the north, move 10 degrees to the west. Beginning from the north, move 10 degrees to the west. This is a compass bearing. Its equivalent three-figure bearing will be its angular displacement with respect to the north. So, it will be this angle. Did you see that? The whole of this angle. So, that will be 90, 180, 270 plus 80 degrees. That gives 350 degrees. So, a compass bearing of north 10 degree west is equivalent to a three-figure bearing of 350 degrees, which is always anyway with reference to the north. So, in describing this line, you can either say it is 10 degrees west of the north, or you say it is 350 degrees away from the north. That is 350 degrees. And when you give a three-figure bearing, it's always the standard that the reference is the north. Alright, now further illustrations. Consider 5 points A, B, C, D, and E as shown below. This is point A, point B, point C, point D, and point E. Now, point B is on a bearing of east 40 degrees south of point A. East 40 degrees south of point A. Or you can say it is on a three-figure bearing of 90 plus 40, which is 130 degrees. So point B is on a three-figure bearing of 130 degrees from point A. that is starting from point A, you need to move 130 degrees to get to a line that is joining point A and point B. Also, considering point C and point B, point C point B is on a bearing of west 20 degrees south of point C. That is, you have to start from the west of point C and move 20 degrees towards its south in order to get to the line that is joining point C and point B. So point B is west 20 degrees south of point C. So also we have another bearing here, and this tells us that point B is east 33 degrees north of point E. That means you need to start from the east of point E and move 33 degrees towards its north in order to get to a line that joins point E and point B. Now, with these representations and bearings shown on the screen, the following alternate angles can be defined. I hope you still remember what we mean by alternate angles. Alternate angles are angles such as angle B and C. It is also called the Z angles. Angle A and D, Z angles. So, with these bearing expressions on the screen, the following alternate angles can be defined. So if this angle is 40 degrees, then this angle also will be 40 degrees because this is a Z angle, 40 degrees. Also, if this angle is 33 degrees, this angle will also be 33 degrees. This is a Z angle. Additionally, if this angle is 20 degrees, so also this angle will be 20 degrees. Alternate angles, remember, Z angles. Also, if this angle is 75 degrees, see the Z angle. This angle will also be 75 degrees. These are important things you need to take note of when you are dealing with problems regarding bearings. You have to have a previous knowledge of corresponding angles, alternate angles, vertically opposite angles, and quite a number of the issues that we have already dealt with when we were dealing with plane geometry. Now, consider 2 points A and B situated as shown on your screen. This is point A and this is point B. Now, the bearing of B from A is 60 degrees. Take note of the ordering. The bearing of B from A, that is the bearing of B starting from A. So starting from A, the bearing of B is 60 degrees. That is, you have to move 60 degrees starting from the north of A for you to get to the line that joins the points A and B. So the bearing of point B from point A is 60 degrees. However, according to the principle of alternate angles, if this point is 60 degrees, so also this point will be 60 degrees. Okay, so therefore, the bearing of point A now from point B will be 240 degrees. You know what we just did? We have said that this point will be 60 degrees. Now we were given the bearing of B from A. Our interest is now in calculating the bearing of A from B. So, starting from B, the bearing of A is this point. That is, starting from the north of B, what is the displacement? The angular displacement of the line that joins points B and A, and that will be this angle. And this angle will be 180 plus 60. That gives 240 degrees. So we were given the bearing of B from A to be 60 degrees. And we have calculated the bearing of A from B as 240 degrees. So when you are dealing with bearing, try to understand that the ordering makes a lot of importance, because the bearing of B from A means the bearing of B starting from A. That is, you start from A to do the measurement. However, the bearing of A from B means starting from B to do the measurements up to the line that joins the 2 points. All right. Alternatively, the bearing of B from A could be said to be north 60 degree east. Remember, based on compass bearing. And also, the bearing of A from B, which is 240 degrees, can be said to be south 60 degree west. Did you see that now? That is, the bearing of A from B, which is 240 degrees, if we don't want to use three-figure bearing and instead just use a compass bearing, we can say the bearing of A from B is starting from the south of B, move 60 degree to the west. That is south 60 degree west. I hope that is quite clear. Further illustrations. Consider 2 points C and D situated as shown below. Okay, such that this angle is 30 degrees. What this means now is that the bearing of point C starting from point D, that is the bearing of C from D, is west 30 degree north. What that means is that starting from the west of D, we need to move 30 degrees towards the north in order to reach the line that joins point C and point D. From the principle of alternate angles, if this angle is 30 degrees, here we have a Z angle. So these two angles are alternate angles, and alternate angles are equal. Alternate angles are equal. So this angle too will be 30 degrees. What that means is this: that the bearing of point D from point C will be equal to 120 degrees. The bearing of point D from point C, that is the bearing of D starting from C, will be this line, will be this angle. The angle starting from the north of C up to the line that is joining the 2 points. So remember that we said that because this angle is 30 degrees, this angle is also 30 degrees. So if this angle is 30 degrees and we know that this angle is 90, so the whole of this angle is going to be 120 degrees. So the bearing of D from C is 120 degrees in terms of three-figure bearing. And also the bearing of C from D in terms of three-figure bearing will be this angle starting from the north up to the line that is joining the 2 points. Okay, but take note that we were given that this angle is 30 degrees. If this angle is 30 degrees, then this entire angle will be 90, 180, 270 plus 30. That gives 300 degrees. So the bearing of D from C is 120 degrees, but the bearing of C from D is 300 degrees. Alternatively, if we want to quote these bearings in terms of compass bearing, the bearing of D from C can be expressed as, take note that this angle is 30 degrees. If the whole of this angle is 120, and we know that this portion of it is already 90. What that means is that this small portion is 30 degrees. Therefore, the bearing of D from C can be expressed as east 30 degrees south. That is, starting from the east of C, moved 30 degrees towards the south. So the bearing of 120 degrees is also equivalent to this bearing of east 30 degrees south. So also, the bearing of C from D, that is, the bearing of C starting from D, which is 300 degrees, we can quote it in terms of three figure bearings as beginning from the west, move 30 degrees north. That is, west 30 degrees north. West 30 degrees north. How did we get the 30 degrees? The whole of this place is 300. Okay? This is 90. This is 90. That's 180. This is 90, 270. Therefore, the remaining portion here must be 30, such that everything will be 300. So, west 30 degrees north. That is the compass bearing equivalent of the bearing of C from D. Example 1. From a point on the edge of the sea, one ship is 5 kilometers away at a bearing of south 50 degrees east, and another is 2 kilometers away on a bearing of south 60 degrees west. How far apart are the ships? Now, this is that point on the edge of the sea. We are told that one ship is 5 kilometers away at a bearing of south 50 degrees east. You see, that is the bearing of south 50 degrees east. And another ship is 2 kilometers away on a bearing of south 60 degrees west, starting from south 60 degrees west. So one ship is here, the other ship is here. And we are told to find how far apart are the ships. This is the distance we are trying to calculate, with this point as 5 kilometers and this point as 2 kilometers. Now, that is the distance x that we are supposed to calculate. Note that when you are given two sides and an included angle, then you use cosine rule to find the third side. If you still remember the points we mentioned on trigonometry when we were dealing with cosine rule. That's why I said in order for you to follow very well this module on bearings and distances, you should have gone through our module first on trigonometry. Remember, this is a caption from the trigonometry module, and here we stated that one of the applications of cosine rule is when you are given two sides and an included angle, and you are supposed to calculate the third side. Now, in this case, you have been given two sides of this triangle and the included angle, and you are supposed to calculate the third side. So, you are supposed to use the cosine rule. What is the value of the included angle? In this triangle we are dealing with here, the included angle is 60 plus 50. That is 110 degrees. So, according to cosine rule, x squared will be equal to 2 squared plus 5 squared minus 2 times 5 times plus 110. I will not go into details of this because we have dealt with it in the module on trigonometry. And if you are not comfortable with these parts of the calculation, like I said, I will refer you back to that module on trigonometry. I think the module on trigonometry is the prerequisite for you to be able to follow through this particular module. Now, according to cosine rule, that says that c squared equals to a squared plus b squared minus 2ab cos c. We have this. So in that case, x squared will be equals to 2 squared plus 5 squared minus 2 into 2 times 5 times cos 110. This gives us x squared equals to 4 plus 25 minus 20 times minus plus 70. Also, how did we arrive at minus plus 70? By going through the module on trigonometry, you will be able to understand how we manipulated cos 110 to make it become cos 70. There we explained it in details. So we go ahead and that gives us x squared equals to 29 minus 20 times minus 0.3420. And that gives us a result x squared equals to 35.84. And that gives x equals to square root of 35.84. And that gives us approximately 5.99 kilometers. So the two ships are about 6 kilometers apart. I do hope you understand. If you don't, please play this example again. It's quite straightforward, and it's one of the simplest questions you can have on bearings and distances. There are very much more complex ones. So I think it's very, very important to ensure that you understand this simplest case before we go into some more difficult cases. All right, now we move on.